Hey guys, dear Finite Math students, this is going to be a reasonably short video because I'm going to show you how to do just one problem in the homework, but it is an important problem. We're going to work on problem 134 in your chapter 3 homework assignment. And it talks about constructing an amortization schedule, which is a table. It's a table. So the problem reads, construct the amortization schedule for a $13,000 debt that is to be amortized in 10 equal semi-annual payments at 6% interest per half year on the unpaid balance. Now, this problem can be a little bit misleading, and here's the reason why. So, semi-annual means twice a year. You're making two payments a year, so that's one payment every 6 months. So you're probably tempted to say, oh, I should do something like this. Divided by, 1 plus 6 divided by 200, which is the same thing as, 1 plus 0.06 divided by 2. Okay? And, that makes sense. It's logical. It is very logical to do that. Okay? Now, the problem is, I already did this problem, so I know what Pearson expects. So the 6% interest that Pearson is talking about, it's really 6% on each period. So you don't have to divide by 2. It's actually 6% on each period. So actually, the annual interest rate is really 12%. It's not 6%. So that's kind of misleading. That's a little bit misleading in this problem, because if you do 1 plus 0.06 divided by 2, if you use this figure, 1.03, you will get the wrong answers. But if you use 1.06, then you will get the right answers, the answers that Pearson expects. So that's a little confusing. That has to do with the way the problem is expressed or worded. It's not really a math problem, it's more of an English problem, okay, if you catch my meaning. Okay, so enough chitter chatter. Let's actually get to work on this problem, okay? Here, let me move this over here. Okay, so as usual, I have my balance function. You don't have to call it balance, guys. Call it whatever you want to call it. You can call it bal. You can call it b. I like to call it balance, but call it b or bal or whatever you want to call it, okay? Balance, period. Oh, and I almost forgot, interest. The interest is going to be 1 plus 6 divided by 100, and I want a decimal, okay? I want a decimal. I do not want a fraction. How do I change this into a decimal? Well, I have two choices. One of the numbers could be expressed as a floating point number, or I could apply the n function, which will change the fraction into a floating point decimal, a floating point number, okay? Shift enter. Okay, there we go, 1.06. So then I have interest times balance, period, minus 1, minus my payment, and I don't know what the payment is yet. We'll figure that out soon. Balance 0. Balance 0 is equal to $13,000. And remember, guys, I didn't actually type the comma. Mathematica typed the comma for me. That's the way I formatted my copy of the software. Okay, it's very simple. You have the option of formatting the software any way you want to. So I did not, let me make sure you understand this. I did not type this comma. Mathematica typed the comma for me. If you don't change the formatting of the software, you're probably just going to get a space instead of a comma, and that's okay. That's okay. I don't have a problem with that. Okay? That's fine. So, okay, I should end that with a semicolon and shift enter. There we go. So the next step is, let me see here. Let me look at the problem carefully. 10 equal semi-annual payments. Okay. And actually, we're not even doing anything with this information right here, semi-annual. So in a way, I kind of wish that whoever wrote the problem didn't even include that word in the problem because it's misleading. Semi-annual means twice a year. So you're thinking, well, I should take 6 and divide by 2. But actually, the annual interest rate is 12%, which means per period or per 6 months, it's actually 6%. So the problem is not worded extremely well. It's slightly ambiguous, okay? But that's not my fault, guys. Blame Pearson for that. Don't blame me. I'm just the messenger. Okay, so here we go. Balance 10. Okay, so that's a little too messy. We should clean that up a little bit. How about expand? Expand. Or we could do it like this, balance 10. And I'll get the same result if I do this, expand. Okay, so that's actually our equation. I have to set it equal to 0, right? So the equation is going to be double equals 0. Okay, notice guys, I'm using the double equals to create an equation, right? Double equals. Okay, so solve equation, and what is my payment? Okay, so the payment is going to be $1,766.28 every 6 months. Okay, terrific. Payment is equal to payment as it's defined on the previous line. Shift enter. There we go. So this is going to be my payment. Okay, so I want to construct this whole table. I don't know if they're going to ask for the entire table or just a small part of it. It depends on the problem, but okay, let's construct the entire table. Let's just construct the entire table. Okay, so what is the unpaid balance going to be? Well, initially it's going to be $13,000, which is really easy. And then the unpaid balance reduction, that's really easy. It's simply $13,000 minus the unpaid balance for the next payment period. It's really, really simple. And actually this right over here, in many books, this is actually called the portion to principal. The unpaid balance reduction is actually called the portion to principal, or the portion of your payment. The portion of your payment that goes to principal. Because if you add this number here plus this number here, you are going to get the payments. So if you add these two numbers, right, you will get this number, which is the payment. You'll see, you'll understand this a little better when I go through the problem, okay? So let's see if we're okay with that. Okay, fantastic. Okay, let's create this table. So let's see now. Unpaid balance is equal to table. Balance n, I think, let me see, balance n minus balance, or if you prefer, well, you could use any letter you want to use. I like n or k, use any letter you want to use. Minus balance k plus 1, and then k will go from, let me make sure I'm doing this okay, from 0 to 9. Oops, sorry, 0 to 9. And the reason I'm going from 0 to 9, guys, is because I have 10, well, I start out with 0. I start out with payment number 0, but then there are 10 payment periods after that. So 9 plus 1 is 10. Okay, you get the idea. Okay, so I'm going from 0 to 9. There we go. And that looks pretty good. And let me, oh, wait one moment. Oops, sorry about that. No, actually, this right here, oops. No. This is my unpaid balance. This is my unpaid balance reduction. This is my unpaid balance reduction. Let me make sure we are okay with this. 1 second. There's conversations going on in my living room, so it's a little hard to concentrate right now. 1 second. Let me just make sure we're okay with this. Yeah, I think this is good. Okay, this is my unpaid balance reduction, and the unpaid balance is simply going to be balance k. K goes from 1 to 10. Okay. And this number here is basically 0. So this number here should really be 0. Right? That number should really be 0. So this number here is negative 5.91 times 10 to the power negative 12, which is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5, 9, 1. So that's basically 0, guys. We can treat that as 0. Okay, that's really 0. All right. Okay, so unpaid balance, we have unpaid balance reduction. And then to figure out the interest, guys, it's going to be the payment minus each of these numbers. Okay, so the interest, let me see here. I'm going to call this portion to interest is equal to payment minus the unpaid balance reduction. Unpaid balance reduction, which is really the same thing as the portion to principal. Okay, so remember, unpaid balance reduction, guys, is really the same thing as the portion to principal. And this, instead of calling it interest, because I'm already using that variable for something else, I'm going to call that list portion to interest. Okay. Now let me make sure that these lists have the correct length. Portion to interest, 10. Unpaid balance. Okay, the list has 10 numbers in it. Unpaid balance reduction. Okay, so we're looking good here. So let me construct the whole table, which will look a little complicated, but I'm sure it's going to be okay. So what should I call it? Amortization table. Okay. So we're going to have the payment number. I'm going to call it N for number. The payment, and I want that. So hold on just 1 second. Hold on I need to put this on pause for just a moment. Okay, so where were we? I just had to go into the living room and talk to a family member. Okay. So payment, and we're going to round that out to 2 decimals. And then, oh, wait a minute. Wait. Portion to interest. So I'm accessing elements within my list. And then unpaid balance reduction. And then finally, unpaid balance. Oh, and I should really round everything out to 2 decimal places. Yeah, number form, okay. Infinity to number form infinity to, and let me do that over here. Number form infinity to, and I think we're good. N goes from 1 to 10 because each list is 10 elements long, or each list has 10 numbers in it. Let's see what this looks like. Everything looks good. This here, I'm not crazy about this. This should really be 0. That should really be 0. So I can change. That's easy enough to change. So we can, that's easy enough to change. So what I'm going to do is amortization table. Okay, that gives me the last row. I want the last element of the last row. And I'm just going to put 0.00 because that's really what it is. It's $0. It's really $0. We're good. Amortization table. Okay, and then we can make this look a little nicer, guys. We could make this look much nicer, actually. So, amortization table, prepend, amortization table. Okay, payment number. And then, 1 second, payment number, payment. By the way, that /n just means I'm skipping a line. You'll see what I'm doing in just a moment. And then interest, unpaid balance reduction, which is really the same thing as the portion to principal, and then unpaid balance, and I believe we should be good. Oh, wait a second. Hold on 1 second. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That should be fine. And grid amortization table. Oh, that looks great. That's perfect. Yeah, that's actually really, really perfect. So let me just make this look a little bit nicer. Okay, so then we're gonna frame everything. We're gonna frame everything, and we could do frame style thick and black, and let's see, the background. Okay, so the columns first. Well, if you do none, and the first row could be light green. Okay, well, that's good enough. And then, I mean, we could do, instead of none, you could make this, you could make that light green. Okay, that's the doorbell. 1 second, pause the video. Pause. Okay, so let's pick up where we left off. So this is our amortization table. This is actually our complete amortization table. So let's see. Payment. Here, let me move this a little bit. $1,766.28, $780 and no cents, and $986.28, and that's going to be $12,013.72. And remember, guys, it's very important that you remember, if I add up these two numbers, okay, I am going to get the payment. That's very important. And where does this number come from? $13,000 minus $12,013. Sorry, $13,000 minus $12,013.72 is going to equal this value right there. Okay, so that's really important to remember. Okay, let's see if we're correct. And I'm going to do the same thing for payment number 2. The payment, the payment is the same. And the interest is becoming a little bit less. And the unpaid balance reduction is becoming a little bit more, 46 cents. And the unpaid balance is $10,968.26. Okay, so yeah, unfortunately, Pearson doesn't want you to do the entire table. If it was up to me, if I was actually writing this problem, I would have students fill out the entire table. Pearson doesn't want you to do that. Pearson doesn't want you to fill out the entire table, just the first couple lines, okay? But yeah, this is kind of an involved problem. There's a lot of stuff going on here, but it's an important problem, and you will probably get something similar on your quiz and your test, okay? What I may actually do as well, I think I'm going to email you, I'm going to email you the Mathematica notebook that I actually used to create the table. That may actually help you. That may actually help you. All right, guys, I think that's going to be it for today. And hopefully this has been helpful to you. All right, take care, and we will communicate at some point in the future.